So I have been told you want to run your Spider 1, the original .NET Gadgeteer board that was made 6 years ago with Visual Studio 2017? Let's talk about that. For those that do not know, FEZ Spider was the very first .NET Gadgeteer mainboard, and it's right here. This is the Spider and the Spider 2. They're extremely similar. You would think they are the same, but that's what the talk is about today. So these two, the FEZ Spider 1 was the very first .NET Gadgeteer product. Microsoft Research had this great idea where you would have a main board, and then this has like a processor that programmed through Visual Studio. Underneath is .NET Micro Framework, and then you would connect modules and you can build a system quite quickly. And this is an example. This is actually designed by Microsoft, and we have made our own copy of it. So it's an acrylic cut, and the beauty of using the wires versus, for example, when you plug in modules, when you stack things up, things get quite big and they are like always in the same place. What if you want a button in one spot or another? They've used these cables where you would wire up like your joystick or a button, different things that you would wire to your mainboard. And then when you make a 3D printed enclosure or just something that you laser cut acrylic, you can build your system quite easily. Now with GHI moving into TinyCLR OS, which is our take on the future of what .NET Micro Framework should have been. Now we're forging that path, and you've seen a lot of releases recently and more to come. We are full-time TinyCLR doing a lot of work in that area. Now, a great idea we had was, why not run TinyCLR on everything? And let's start with everything we have ever made. Why not? It's very portable, and we can show you how to port TinyCLR to these products, and then you can take it from there and port new products. Now, this is where the challenge came in. Let me back up a little bit here. So TinyCLR OS would be running on Gadgeteer board, but that's not Gadgeteer. And we're trying to find ways, because TinyCLR OS replaces .NET Micro Framework. Once you have a system running TinyCLR OS, you're using Visual Studio 2017 today, and whatever comes in the future, we're going to work on supporting that. Actually, we want to support other IDEs as well, and that's in the plan. And then there's also .NET Gadgeteer software, not the hardware, the software that runs on there. The Gadgeteer Core is what it was called at some point. We want to replace that as well, but we have discontinued Gadgeteer, unfortunately. So we're going to do the part that cannot be done by the community, like the most complex pieces that are really hard to make. We have support team over here. They'll figure that out for you guys. And then for the Gadgeteer piece, the software, we're going to do like some starting point and get you going. And then from there, the community should be quite easily build drivers for modules and design whatever they want to design around Gadgeteer. And we did tech talks before about this, and we'll do more in the future. Of course, jump on our forum, the new forum that now we have, and please discuss with us what you think and what we'd like to see. Now, circling back to Gadgeteer. So you have Gadgeteer or an older product from GHI for that matter, or non-GHI, and you want to run TinyCLR OS on it, we are here to help. And we have been running TinyCLR on a lot of Cortex-M, specifically the STM products publicly. We did ARM9, and now we want to run TinyCLR OS on the original FEZ Spider. The original FEZ Spider uses, so if you look at these two, they look exactly the same. You look at the back, and they still look very, very similar. One uses G120, this one right here, and one uses EMX. These are the core, our system on modules that are used commercially to build products. So these two compute modules that are sitting here on the back, they are awfully the same. Actually, the processors both come from NXP, and they are so close. USB, all peripherals, SPI, UART, GPIOs, everything is almost 100% the same. So you would think it can be easily done. We can just port the already available G120, which is Cortex M3 from NXP, to the older ARM7. Well, it turned out to be a lot harder than we thought. Cortex did a really nice job on implementing timer, a system timer right into the processor, not a peripheral, right into the core that NXP, for example, licensed from ARM directly. So the core processor, it's not just an engine that executes code. It also has a built-in timer and a built-in interrupt handler. So all the interrupts are handled by the processor. Why this is nice? Well, if you write code to handle interrupts, or if you write an operating system that uses timer, every operating system does, or if your code uses interrupts, for that example, your code will run on any Cortex M 3 and 4 and 7 and M0, I think it's very close. So automatically, whether you get it from ST or NXP or TI, they all license the core ARM from ARM directly. The Cortex M3, M4, M7, etc., the core that goes into the processor. Now, the peripherals around it are different, and that's what we provide in TinyCLR OS port. So we give you the core that runs on M3, that already has timers and everything. It just works. You have to give it a UART driver or USB driver, and you're already talking to TinyCLR OS. It's quite simple, extremely simple compared to how things was done in .NET Micro Framework before. Porting .NET Micro Framework was not fun at all. And talk to anyone who've done it before and have them compare it to TinyCLR OS. They'll see the difference immediately. Now, on the ARM7, things work differently. There was no interrupt handler built in. The processor had just the one interrupt. Well, there's IRQ and FIQ. FIQ was not really used. The IRQ interrupt, it's basically inside just a one signal going from the processor to something. And that something is an interrupt controller on this NXP chip, LPC2478, I think. 88. So we had to sit down and figure out the startup code, the interrupt, the timer. It was a nightmare. To me, it was, it's the same chip. So yeah, we'll spend a couple days and we'll have EMX running and we'll have Spider working. It was not fun at all. And this just happened right now that they gave me this demo running on EMX, therefore running on FEZ Spider. So yes, right now, this second, I can plug in my FEZ Spider 1, the original one, the very first one. I can plug that into my PC and deploy a program that runs through Visual Studio 2017, Community Edition if you want, and deploy that on the original FEZ Spider. Sounds really good. Now, to add more to that good news, which this will kind of ruin the surprise, but I'm too excited to wait for this. The code should run as is on the original FEZ Panda. We haven't tested it yet, but the two processors are ARM7 made by NXP. They are very close, if not the same. I might be able to just take the firmware, drop it on the original FEZ Panda, it will work. Is this available to you? No, not yet, because we just got this working and we're doing a lot of tweaks here, and there's a lot more to come in the next week or so. So stay tuned. We'll talk to you next week.